Let's continue on with number 6. If f is a continuous function and if big F prime is equal to little f for all real numbers x, then the integral from 1 to 3 of f of 2x dx is equal to what? So again, anytime I see composition, we're going to immediately say, let's let u be the inside. So du is going to be 2dx. So the first thing I want to do is go ahead and f of 2x times, I'm going to put a 2 inside, countering it with a 1/2 on the outside. Don't forget the dx. But we do need to, before I use u, we do need to change our bounds. So when x is equal to 3, u is equal to 2 times 3. If x is equal to 1, u is equal to 2 times 1. So this can be the integral of from 2 to 6 of f of u du. Now we do know that little f is the derivative of big F. So big F is the antiderivative of little f. So the integral of f of u would be big F of u evaluated from 2 to 6. So I have 1/2 times big F of 6 minus big F of 2. And we can distribute that 1/2. We get 1/2 big F of 6 minus 1/2 big F of 2. All right, number 7, the integral from 0 to 1 of e to the negative 4x. So we're going to do the same type of thing here. Let u be negative 4x. du is going to be negative 4 dx. We don't have a negative 4. So no problem. I can put in a factor of negative 4, balancing it or countering it with a negative 1/4 of dx. Let's figure out what our bounds would be. So if x is 1, u is going to be negative 4. And if x is 0, u is going to be 0. So again, be careful to put those bounds in the same order. The reason I do it this way is I always do the top one and the bottom one first. So I always do the top bound, bottom, so that way these stay in the same exact order, 0 to negative 4. Now we can and we will switch them, but don't just switch them. So this becomes e to the u du. Okay, and don't forget the negative 1/4 out front. All right, so I get negative 1/4, and we are now going to switch the bounds. So we're going to say from negative 4 to 0 of e to the u du. But remember, when you switch the bounds, we negate. So that's going to cancel out that negative. So I end up getting a 1/4. The integral of e to the u is e to the u from negative 4 to 0. So I get 1/4 times e to the 0 minus e to the negative 4. E to the 0 is 1. E to the negative 4 is 1 over e to the 4th. So I get 1/4 minus 1 over 4 e to the 4. So 1/4 minus e to the negative 4 over 4. Okay, just recall again, I can always bring up anything I want as long as I change the sign of the power. Number 8 is very similar to one that we did in the assignments, and then I went over it as well in class. Because of this quotient, we're going to have that difficulty, but again, this is a difference of 2 squares. So without changing anything yet, I can factor the top. That way the x plus 1's cancel. Technically, I could substitute and let u be x minus 1, but du is 1. So this does just integrate very, very nicely on its own to just be x squared over 2 minus x evaluated from 1 to 2. Let's plug in 2. So I get 2 squared over 2 minus 2 minus 1 squared over 2 minus 1. 2 squared is 4. Divided by 2 is 2. Minus 2 is 0. Minus 1 squared is 1, so I get 1/2 minus 1 is negative 1/2. 0 minus negative 1/2 is 1/2. Number 9, let f be the function such that the integral from 6 to 12 of f of 2x dx is 10, which of the following must be true. So this is one of those more like setup type of problems. So we're going to say u is 2x, du is 2 dx, x is 12, and 6 are my bounds. So u is going to be 2 times 12 and 2 times 6. Again, I need a factor of 2 inside, so we're going to put a 1/2 on the outside. So this will equal 1/2 the integral from 12 to 24 of f of u du. So this whole thing here is 10, which means, doubling both sides, the integral from 12 to 24 of f of u du is 20. Number 10, u is going to be the bottom, 5 minus 3x, du is going to be negative 3 dx. So one of the first things I would do here, just to kind of keep things in order, I generally would pull that dx off the top and leave that as 1 over 5 minus 3x. And then I would put my negative 3 in, countering that with a negative 1/3. My bounds are 4 on the upper one and 2 on the bottom one. So plug in 4, 3 times 4 is 12, 5 minus 12 is negative 7. Plug in 2, 3 times 2 is 6, 5 minus 6 is negative 1. So we're going from negative 1 to negative 7 of 1 over u du. I'm going to go ahead and switch those bounds. So put the smaller one on the bottom, which is going to negate the coefficient. So it makes it just 1/3. You're going to go from negative 7 to negative 1 of f of u du. The integral of f of u is the ln of the absolute value of u. This is where it becomes important to know that it's absolute value, because ln is not defined for negative numbers. So you can't put in negative 7 into the ln. You'd have to take the absolute value. So I get 1/3. The ln of the absolute value of negative 1 minus the ln of the absolute value of negative 7. Absolute value of negative 1 is 1. The ln of 1 is 0. Absolute value of negative 7 is 7. It gives me just the ln of 7. So I end up getting negative ln of 7 over 3 as the answer. That takes us through number 10. The next video will take us through 11 and, well, through number 15.